The mass M in kilograms of the Caribbean grooved shark is known to be proportional to the square of the length of its dorsal fin in centimeters. And so they're giving us this equation here. So the mass is, so what's this K? This is a constant of proportionality. It's there to make it an actual equal sign rather than saying, well, M and the length squared, L squared, I guess, are sort of isometric. They grow at the same rate. So we've got this actual K here to make it an equal sign so we can properly model mass as an equation given the length of this shark's dorsal fin. So here we got this nice little equation here, and all we're being asked is find the units of this proportionality constant K. Okay? So let's just take a look at the units we have on either side. For this to be a proper model to respect dimensional homogeneity, all the fun buzzwords, we need to have units on the left equal units on the right. So on the left, what have we got? We've got the mass, and it's in kilograms. Then we have whatever the heck the units for K are, which we don't know. We're going to solve that. But what are the units for the length, L, here? So that's centimeters. And then we're squaring the length of the grooved shark's dorsal fin. So we get centimeters squared. So in order to balance things out, we need the right-hand side to be equal to kilograms, which means we need to get rid of the centimeters squared. So we'll divide by that, but then we also need to introduce kilograms and multiply that. So we can just sort of come along and say, all right, what's missing? This has to be kilograms over centimeters squared. That way the centimeters squared cancel out, and we're left with kilograms on the left like we have, or sorry, kilograms on the right like we have on the left. So K, in this case, has units of kilograms per centimeters squared, which should be some model of pressure. Not that we're here to interpret that sort of thing. Is that pressure? This is mass per centimeter squared. No, sorry, force. Force per centimeter squared would be pressure. So we don't have that. This is just mass per centimeter squared. So I don't know the fancy SI buzz term for that, at least not off the top of my head. Not that we were asked for that. Not that we're being asked to interpret. They just want the units for K. There you go. It'd be kilograms per centimeter squared.